Okay, so typically what we have been talking about, okay, what we have been talking about was compounds. So we have been putting two or more elements together in order to form a compound. So that's what we were doing last unit when we were writing the names of formulas and learning how to write formulas from their names. Okay, so we take like, you know, sodium and chlorine and we put them together and we get sodium chloride. And we learn how to do that whether it was covalent or whether it was ionic. Okay, so now this next unit, we're really kind of getting into what people would define as quintessential chemistry, and we're going to be doing chemical reactions. Okay, so now instead of taking, now we're going to take those compounds that we were formed and we're going to chemically mix them with other compounds. Okay, and when we mix them with other chemical compounds, when we mix them chemically with other compounds, we're going to make new stuff. So remember way back, way back last semester, we talked about sometimes you knew you had a chemical reaction if you produced heat or light, or you saw like a color change, or you formed a precipitate where it was a solid. Remember like way back at the beginning of the school year, I had those two clear liquids in those test tubes and I mixed them. And when I mixed them, one of them turned what color? Yellow. One of them turned yellow. Okay, so that was a chemical reaction. Okay, all right, so just as a quick start on some of the stuff that I want to hit that sometimes trick people up, let's start with first, since we were talking about the periodic table, let's start with something that these are called diatomic elements. Diatomic. When you see the di part, di, what do you think? Two, exactly. Yeah. Exactly, two. And then when you see the atomic, what word does that sound like? Atom. Two atom. So these are going to be two atom elements. I haven't talked to you about these, but they're very important because especially when we start to balance equations, this is typically where people mess up, okay? There are 7 diatomic elements. And what that means is when it says two atoms, it essentially means that when they're by themselves, it's a twin. Okay, they come in a set of 2. Okay, so they're always like, if you saw like lithium, it would just be lithium, but there are 7 that come as a twin, so they have a subscript of 2 behind them. Okay, now here's the great thing about it to help you remember it. Okay, there are 7 of them, and on the periodic table they make the number 7. Okay, so it's these right here. Who has found something wrong with what I said already about them being 7 diatomic elements? There's only 6 here. Okay, so there is one more. He's over here. It's hydrogen. Okay, so hydrogen is also included. So make the number 7 and then don't forget to pick up hydrogen. All right, so again, these are twins. So when you see them by themselves, not if they're combined with someone else, okay, but if you see them by themselves, they are a twin. So for instance, hydrogen is really H2, okay? Nitrogen is N2, oxygen, fluorine, chlorine, bromine, and iodine, okay? You don't have to say dioxygen or dihydrogen or diiodine, okay? Okay, it's just chlorine because they just come that way. It's just a twin. It's just a twin. Okay. All right. So they are twins. Now this is important because in a little bit we're going to talk about conservation of matter or conservation of mass. What does that mean? We've heard that law before. What's the law of conservation of mass or conservation of matter? What does that mean?
Cannot be created or destroyed.
Exactly. It cannot be created or destroyed. And so when we start talking about equations, we're going to make sure we have the same number of atoms of stuff on both sides. Okay. So if you forget to put a 2 on there, that totally throws off your count. All right. And if that throws off your count, it's going to be really hard to balance it, which we're going to learn how to do. Okay. All right. So the first thing is make sure you know your 7 diatomic elements. Okay. So that's going to be important. The next thing I want to talk about just for a second is the layout for a chemical equation. Now, if you have equations in math, an equation in math, how do you know you're looking at an equation in math? What do you normally see? An equal sign. An equal sign. What'd you say, Whitney?
It has multiple parts.
It does have multiple parts, and you also see an equal sign, okay? So in science, we're gonna have equations, okay? But instead of the equal sign, we're gonna have an arrow, okay? An arrow. So this arrow is kind of like the equivalent, it's kind of like the equivalent of the equal sign in math, okay? It's kind of like the equivalent. So what this arrow means, it means, you'll hear it called two different things. Sometimes people will say yields, or they may say produces, okay? It is essentially your equal sign though for your equation. So if we have that, that means we probably should have some stuff on either side of the equal sign, okay? On the left side of our equal sign or our yield or our arrow, okay, we're gonna have reactants. Guess what reactants do?
Yeah.
They react, okay? This is the stuff that we start with, okay? And they react together. They react together chemically, okay? And then the arrow is saying, hey, after the reactants react together, they make some stuff or they produce some stuff on the other side. Guess what they produce? That sounds kind of like produce. What can you produce that sounds like produce? Any guesses? I'll keep writing slowly, slowly. Products, excellent. Okay. So your products are the stuff that you end with, okay, or your end result, okay? So you can have anything from like, you can have one reactant and it could break down into multiple products, or you could have 2 or 3 or more reactants and they make 2 or 3 or different products. You can have 2 reactants and they can make 1 product, okay? You have a lot of different things you can do, and we're going to talk about that because there's 5 different types of equations. We're going to learn about that on Wednesday, okay? So far, you got to know your diatomics. You have to know the stuff you start with is called reactants. The stuff you end with is called products. The sign, the arrow in the middle is the yield sign, okay? Or it means produces, okay? So now let's do 1 or 2 quick examples, okay, of going from a word equation, which is what we're going to be doing mostly on Wednesday, to the formulas that we've been writing, okay? So this is why it's important. You have to know how to name. If you don't know how to name, you need to figure out how to do it really quickly. Remember, there's videos on the front page from every class where we write all this stuff, okay? All right, so I'm going to give you an example of an equation, okay? We're not worried about balancing yet, okay? That's where the law of conservation of energy comes in. But I want you to be able to write what we call a skeleton equation. So basically, if I give you the words, can you write it in formulas, okay? All right, so I'm going to start erasing slowly from here. I should have saved that, huh? Let me see if I can save that. I'll take a quick picture. I'll see if I can put that. All right, so now I'm going to erase. All right, so I'm going to give you, again, a word equation, and we're going to figure out what it is in formulas. All right, here we go. Let's try, okay. Now, eventually, we're going to get to the point where I'm going to stop after the word produce, and you're going to be able to tell me what it makes on the other side. We're going to learn how to do that too. Ooh. All right. So this is the kind of stuff we'll be looking at on Wednesday. Tricarbon, octahydride, and oxygen produce carbon and dihydrogen monoxide. So you're going to have to go from there to formulas, okay? Take a second, think about it. Think about it for just a second. And then we'll start going through it, okay? All right, anybody want to start me with all formulas? It should be all formulas, Meaning the stuff we were writing last time, like a formula. So I'll show you.
Okay.
All right, so for example, I'll give you some hints to start. Anytime you see "and," this is probably going to be a plus sign. So I got a plus sign here. I'm going to have a plus sign here. What about produce? What do you think I should do right there?
The arrow sign.
Mm-hmm.
Equal.
Produce is going to be my arrow side. All right, somebody online, tricarbon octahydride. Tricarbon octahydride. Someone online, what you think? What's the formula for that? You can walk me through it if you need to think through it.
C3.
C3, excellent. Hydride. We haven't really used hydride. Any guesses though?
There's one in the chat.
Yep, and he is correct. That's Annis, he says C3H8. Excellent. Hydride is H for hydrogen. So C3H8. Excellent. That's the tricarbon octahydride, and that's the plus sign. Oxygen, I need oxygen.
Oh.
Okay, Marco says O, and he is close.
H1. No, wait, H1.
Anybody know why? What else?
Needs the two.
What'd you say, Dominic?
Needs the two.
It needs the two. Oxygen is one of the twins. Excellent. So that's what I mean by you have to start to, and I expected somebody to do that. I'm going to be honest with you, okay? That's what I mean by we have to get used to the twins, okay? So if you have to write them down to start, that's fine, okay? So you got to make sure that you know when you're dealing with a twin, okay? And let me clarify, it's only if they're by themselves, okay? So for example, on this other side, we have carbon dioxide. Carbon dioxide, what am I going to write for that?
CO2. Yeah,
Yes, no?
yeah, CO2.
Okay, Eric says CO2, C would be carbon, dioxide would be O2, that's correct. Now, had I said carbon monoxide, that 2 doesn't have to be behind that oxygen. It's only if oxygen's by himself. So I could have had CO if I said carbon monoxide, or I could have had CO4 if I had said carbon tetraoxide, okay? But if he's by himself, they have to be a twin, okay? All right, so and now I have dihydrogen monoxide, dihydrogen monoxide.
H2O.
Excellent, and it's H2O. Okay, so that's what we're going to be working on Wednesday. We have to go from words, so you can see how if you are, now it's different if you're just kind of still pushing through, but if you're like, I never actually learned how to name, I just Googled all this stuff, it's going to take you a very long time to do all these assignments, because I promise you, you probably can't put that into Google and find this equation. I mean, okay. All right, so that's what we're going to be doing on Wednesday. Let me see. Do I want to give you one more? I'm not going to give you one more. Actually, yeah, I will. I'll give you one more, okay? So let's do one more. All right. And then that'll be it. And then you'll just have your quick quiz that you'll have to do before class on Wednesday. You know, I don't usually give you guys homework like that, but it's a quick quiz, okay? You will, listen, someone's gonna say, how am I supposed to know this from the quiz? I don't see anything. There is a video link in the instructions. Open the quiz, open the video, watch the video, answer the questions to the quiz. All right, let's do one more quick one. How about, should I make it hard?
No.
No?
Fine.
All right, let's do something else then. Let's do. And let's see. I should have started further over. Ah. Okay. I was going to give you one with Roman numerals, but I decided not to. All right, sodium chloride and magnesium bromide produce sodium bromide and magnesium chloride. And I just want to remind you, by the time we get to the end of this unit, I'm only going to give you this part. And you're going to have to come up with the rest and give me the full balanced equation, okay? All right, so I'll give you a second to think about it, and then we'll do that one and we'll be finished for the day. All right, let's do this one. All right, and I'm gonna show you the best way to do this. This is what we're gonna do next week. All right, so a lot of you, well, at least two of you gave me the same answer and you both made the mistake I assumed you would make, okay? But that's not a bad thing. All right, we got sodium chloride, sodium chloride. Eric says sodium is Na, and he said chloride is Cl, and he's correct, okay? And that formula is correct. How do I know this formula is correct?
Because they both equal 0.
Yes, because they equal 0. Nice job, Marco. This is +1, and this is -1. And in a second, people are going to start to figure out their mistake. All right, and what should I put for and?
Plus.
Plus, very nice. Magnesium bromide. All right. Some people told me magnesium bromide, MgBr. Looks good.
2.
Maybe. Excellent. Nice. People are picking up on their mistakes. Magnesium has a +2 charge. Bromine has a -1 charge. So this is actually MgBr2. That's what people are forgetting. Okay. Produces. There's my arrow.
SbR2.
SbR2. Are you sure? Na, there's your sodium. Here's the good thing, right?
Looking at the wrong one.
Right, exactly. Here's the good thing. Once you get your letters and charges on the left side, your charges should carry over. They're not going to change. Your formula might change, but your charge is going to carry over. So you have sodium. Here's your +1. Bromide, that's Br. This was a -1. So that formula is right. And that's plus. Magnesium was what? Mg with a what though? What charge?
Positive.
It's over here. +2. Chlorine is what? Cl with a -1 charge. So this should be MgCl2. Excellent.
Is it just sodium and then the outside ones and the inside ones go together?
Yes, and that's the type of equation that we're going to talk about. So Eric noticed that they just kind of did a do-si-do. They just kind of switched. And that's the type of equation that we're going to talk about, okay? So the big thing on this one is it's super easy not to write your formula correct if you don't write your charges to start. Now, eventually, I will figure like in the next week or two, you guys will be able to do this without writing your charges, okay? But this is what we're going to be doing on Wednesday. You guys are good to go. Let me just show you your quiz where it is. I'm going to stop the recording.